Good morning, all. Amandeep, I'm your moderator for the day, and I lead the industry initiative at NASSCOM Pune. I, along with my team, welcome you all. In today's webinar, we will be discussing on how an organization can get the big data ready for machine learning and advanced analytics. More than 90% of big data is unstructured, and every organization is at a different stage in the big data journey. Once an organization starts maturing in data collection and processing, the next question is how we can maximize the business value. And to share knowledge around this, we have the industry expert with us today, Mr. Prashant Pawar. He is the lead technology advocate at Nihilent. He has more than 2 decades of experience in big data, analytics, data warehouse, business intelligence, Azure cloud services, search, GIS, and open source, just to name a few. Talking about Nihilent, it is one of a global consulting and services company, renowned with a significant presence in India, UK, US, Australia, and South Africa, and one of the CMMI level 5 appraised and ISO 9001 certified company. We extend thanks to the Nihilent team for sharing the knowledge on one of the most talked about the topics, that is getting your big data ready, along with the live demo. Now we will be starting with the webinar. I hope you're all able to hear me. In case you're not able to hear us or there is some issue while the presentation is being shared, please do raise your hands using the raise hand button and the team will address your queries. If you have any specific questions while the content is presented, you can start posting on the question panel that you see. At the end of the webinar, the speaker will definitely be picking up on the most of the questions and addressing queries. So in order to get your query addressed, please start posting as the content is going on, and we will pick up those questions at the end of the webinar. I would now give the presentation rights to you, Prashant, and request you to take it ahead from here.
Yes, thank you, Amandeep.
Over to you, Prashant.
Yes, thanks, Amandeep. Are you able to see my screen?
Yes, I'm able to see your screen.
Yeah, so hello, everyone. It's great to be talking to all of you today. Thank you for joining this webinar. The topic for today is getting big data ready for machine learning and advanced analytics. So I will start with a little bit about myself. I'm Prashant. I work as the lead technology advocate and I lead the Microsoft practice at Nihilent. And I'm primarily responsible for helping our customers with their big data strategy, intelligence, and machine learning. Concerning evolved ourselves more as a problem-solving organization. We have multiple delivery centers globally, like the ones at Minneapolis and Dallas in the US, at Cape Town and Johannesburg in South Africa, and 4 delivery centers in India at Pune, Mumbai, Kolkata, and Chennai. Based on our design thinking approach, we have 4 key offerings: enterprise consulting, digital services, data science and analytics, and IT services. In addition to being one of the first implementers of modern data warehouses, we've been in application of RPA, SAP on Azure, and IoT. We are a gold partner for SAP and Microsoft, and I'm very proud to mention that we are the winners of the Microsoft's Gold Partner of the Year award for Power BI. All right, so let's look at what we are going to cover today. In order to set the context for today, I would like to start with a very quick look at some of the machine learning based solutions that Nihilent has developed and also broadly look at some more examples of how unstructured data is being used today for machine learning. And after that, we will talk about the data journey and also look at a demo of an NLP process just to illustrate the complexity involved in the processing of unstructured data. And then that will bring us to the challenges that are involved in handling big data and how you would want to master those challenges. And last of all, I will walk you through a case study. So very quickly, just to set the context, here are some of the analytic solutions that Nihilent has developed. Part of these solutions are based on machine learning and natural language processing. The warranty analytics solution is applicable to any industry, and it provides valuable insights into patterns like the trends of the warranty claims and the nature of the claims. But the most important part is that it uses natural language processing to read the text or the notes that are written by the customer service engineer, and it uses that knowledge to classify the claims automatically into different categories. And it also helps in fraud prevention. Similarly, the social media analytics uses NLP again to capture the sentiments of the customers from Twitter and Facebook, and it extracts quantifiable data from the opinions expressed by users in the forms of comments and shares. Now, here are some more examples of unstructured data for analytics, and I'm pretty sure that you would be having your own examples as well. And I'm not going to go through all of these, but this is just to give an idea about how industry is now making use or planning to use unstructured data for analytics. So it could be retail industry or insurance or finance or legal or even manufacturing. The insights gained from unstructured data can be used in multiple places. The most important of it is basically how do you use it for analyzing the voice of the customer, or how do you streamline your customer service, or even how do you get the insights into customers' thinking and behavior. So all of these goes into a lot of planning in terms of how do you get this information out from the unstructured data. There's a lot of business operations that can be streamlined using this data, like purchase orders and invoices and spend analytics. There's a lot of knowledge management that can be done using unstructured data as well. So what has happened in this over the years, the machine learning and NLP, particularly last 2-3 years, it has improved a lot. If you have been working in this space for last few years, you must have noticed that there are many libraries that are available as open source to every one of us, and these libraries have matured tremendously. They serve some specific purpose, and they can be used in combination as well. At the same time, there has been a tremendous growth in or at least maturity in the models that have come out. And these are all deep learning models like CNN, for example, or LSTM, the long short-term memory models. And these models have matured also over the last couple of years. You have something like TensorFlow, which came in the year of early 2017, and now it has become one of the most important platforms. And on top of all these libraries and models, what has happened is a lot of cloud service providers are providing SaaS or PaaS services. And also they are providing APIs to do a lot of the work that you would have done previously using all the libraries that you see on the left-hand side. So all of these have been positioned as platforms, and the complexity involved in building your machine learning programs or models, it is all encapsulated behind the scenes. And organizations like Microsoft giving Lewis, or IBM coming up with IBM Watson. So these are just some of the examples where ready-made cloud services and APIs are becoming available for us to do machine learning and artificial intelligence. So I will quickly just show an example of how these APIs, the work, and they make the life easy for us. So if you look over here, this is one of the APIs provided by Microsoft in the Azure environment for text analysis. Now, if I quickly put some content, let me take some content over from here, and you know how easy it has become now to do NLP or machine learning. We will take a quick look at it. So if you look at this, I just put some content over here, a piece of content, and this service is already running in the cloud from Microsoft in Azure. The model has already been trained by Microsoft, and what I'm supposed to do is right now just try to get a few things out of my text. So one is I want to know what is the language or what is the sentiment that this text gives me so that I can classify it as per the sentiment. There are several other things as well that this model gives me. For example, it tells me what are the named entities within the context or within the document. It also tells me what are the PII entities. That would be very valuable information for me, especially if I have to do a lot of data security on my content. And it will also enrich my content as well. So if you see over here, the same content that I had entered, it will actually go, and if you see, it will give me, it has taken Tony Robbins' Wikipedia page, and it has actually created a link for me over here. So there's a lot of content enrichment also that these APIs nowadays provide. So all in all, NLP or machine learning is getting easier by the day. There are APIs that are being available. So not only just libraries that we were talking about, nowadays there are APIs. So if I want to build an application, and if it's a simple application, I need not actually try to build my own servers and then on top of it try to learn this about these libraries and then build a model, then train the model, and then create an application. Right? So my application can directly actually use these APIs and get the required uh, insights out of this by using the machine learning that this cloud or the APIs provide. If you look over here, you also see a JSON. So this is the JSON that my application can actually consume. This is what has been returned to me by this particular API. One interesting thing I always like is that it gives a sentiment about at the document level, and then it also goes one level down, like to the granular level of each. It would give a sentiment about each sentence as well. So there are these APIs that are available not just from Azure or Microsoft, from all the major players that are there in the machine learning space. But what happens is this looks to be okay for simple applications where I want to do small level of machine learning, and my applications are not very complex. But typically in an enterprise environment, your unstructured data will be very large and it will have to undergo many steps actually. You will have to do a lot of data cleaning, a lot of uh, linguistic processing as well on that data. So what happens is if you look at the structured data, right? So before getting into unstructured data, let's see what is the difference between how you process structured data and unstructured data. So in structured data, typically you will have three broader steps. One is you first do data cleaning. You fix data issues, you fill in the missing values and so on. Then you do some kind of a data standardization. And typically this data is already structured. Most probably it is in a relational format that you have already got it. So you do some data standardization if you have to combine data from multiple sources. And lastly, you do the data transformation where you have to apply some business rules or do some aggregation or categorization. So broadly, you will have these three steps in structured data. Now, in your particular project, you may have one or more steps, but broadly, you can categorize into three broader groups. But in unstructured data, what happens is, well, first is you don't have the data in a relational format. So you have to start with extracting the data first of all. So you first you would capture the data as it is in a raw format. Then you will start extracting some structured knowledge, right? So first you would do a data cleaning. Then from data cleaning, you would try to extract such structured knowledge from that data. Like in the last live example where we saw that we try to extract sentiments, you try to extract entities, you try to extract the PII information that is or sensitive information that is there. So all that extraction needs to be done. And then you try to do data standardization. So if you're getting data from multiple different source systems and you need all of that for your machine learning project, then of course you have to do standardize the data from coming from multiple source systems. Then you do data enrichment, right? In the last example, as we saw, the data was enriched by by adding the link of that particular person, the Wikipedia page of a particular person. So there's a data enrichment that happens. And then you come to data transformation where you want to apply your own business rules, or you want to do some aggregations on top of the data. And lastly, this is an important step, right? I mean, in terms of unstructured data, you have to convert everything into vector. And that is what the machine learning algorithms will understand. And so if you see, you have much more steps to do in an unstructured data processing compared to a structured data. And this looks at a high level, it still looks manageable to us, right? The 6 steps, if you say more or less, if you add 1 or 2 steps, still it seems to be manageable. But actually, when you start doing a project, you quickly realize that there are many steps or under each of these 6 buckets. So just to give you a sense, and I think if people in this audience, they have already worked on using NLP or have done machine learning, then they probably are already have gone through this entire cycle of going through multiple steps. And this gives just an overview about what all things you need to do in all of these different 6 steps that are there. Just look at text cleaning. I mean, you might not do all of these, but at least if you do some of these, I mean, you have to do, to remove unwanted content like HTML or punctuation tags, or you have to remove stop words. You have to probably convert everything into lowercase, delete redundant or useless data. After that, you have to get into linguistic processing, use different libraries that are available over there to finish linguistic processing like stemming or tokenization. Then after that, you get into extracting structured knowledge. Again, you have to do different things, right? There's no one single library or one single function which lets you extract all the knowledge that you want. So you have to go through multiple steps to extract the knowledge. Then you have to do data standardization. And within data enrichment, there are multiple things probably you have to do. Like you have to, especially if you're in a legal industry, you'll have to cross-link or cross-document those references, or even you'll have to calculate the textual similarities. And during all of these steps, while you're doing this, you have to store the content very methodically so that you can use it again and again. Because machine learning, as you know, it is more of an experimentation kind of a project where you just cannot do it once and hope that you will get the best model or the best output from that. So you'll have to learn over the process, and therefore you have to probably do these steps and the sub steps multiple times during your entire project. So what happens is, uh, just to see how this, I mean, right now we are just looking at this on the screen, but to get an idea about how actually it looks in a live project, let's go and take a look at one other experiment that I have here. Again, this is a demo I have on Microsoft's Azure Machine Learning service, and what I'm using or what you're seeing over here right now is the Azure Machine Learning Studio. And what I'll show you is that this is an example where what we are trying to do here is we are trying to do text classification of Twitter feeds or tweets that are coming that have been captured from Twitter. And in this example, we have around 160,000 um, 160,000 tweets, and we are going to classify these tweets uh, into two categories primarily. One is positive, and one is positive tweets and negative sentiment tweets. So if you just look at this, the amount of work that still goes on into creating this kind of a model is that you end up having almost 6 different steps that you would have to do. So the first step is usually, you do some data preparation. Now, within data preparation, you're going to import the data from wherever your Twitter data is coming from. If it is coming in live stream, then you have to get it into a live stream format, or if you're getting it in batches, you still have to import it from somewhere. Then you have to select the columns or the fields that you are interested in. Then you have to edit the metadata. You have to start cleaning the metadata here itself. I mean the entire data here itself. And then you have to think about doing the partitioning, sampling of the data, and so on. Then after that, you're still not done, right? This is just a beginning. Then you get into text pre-processing, right? So where you have to start cleaning the data. So if you look over here, for example, I have to replace all my special characters, or I have to remove all the duplicate characters from there. I have to replace the numbers in this particular case. I have to convert everything to lowercase. So there are multiple things that we end up actually doing in a simple thing that we thought was I just need to classify tweets into two different buckets, but I'm already now having done so many different activities, and then I'm still not done, and then I have to figure out how am I going to actually uh, which features am I going to use in order to classify my tweets. And that's where you will come across different options that are available, right? So do you use word of bags um, for basically this processing, or do you use ngram for processing? So different options are there. Now in this particular case, we are using ngrams for processing or feature selection. Again, there are some steps, and then if I go further, um, finally I have my model, and then I want to run my model. So I have use two different algorithms over here. So let me just little bit go up over here. Yeah. Um, so I want to try two different models, and I have actually you can see two parallel streams over here. One uses ngram, and the other one uses the bag of words representation model. So both of these models are being run, and then finally I do a scoring on each of them to see which one is faring better for me, and then I finally evaluate the model. So here, after doing all these steps in 4 different processes, I have finally reached a place where I'm evaluating a model. And then finally, last of all, I actually have to execute the model, deploy it, and make it available as a web service finally to my end users. So multiple steps are involved in creating or processing the simple example that I talked about of the classifying the tweets. So just to see how this looks like, I'm just going to run this very quickly. I'm not going to run all the 5 steps. It will take a lot of time actually, but this was just to give you an idea about the number of steps that are typically involved in processing unstructured data if you want to use it for machine learning or artificial intelligence. So let's run this and we'll come back to this one. Yeah, so it is going to take a while actually while we run this. It is currently queued and it is running, if you can see here. But what I'll do is I already ran, so for the sake of time, I'm going to go and actually show you this web service output, how it looks like, because I already kept it ready just before we started the webinar. So if I go here, so this is where I will actually see the web service that it has created, and I can actually now test a new tweet that has come, and I will see whether how that tweet looks like. Is it positive or negative? So if I click here and if I say today is nice and sunny, uh, I would like walking outside. Let's say this is a tweet that I made, and how is it going to classify this? So if you see, it gave me a score of 0.7. So 0 is basically negative or negative sentiments, and 1 is positive sentiment. So it is telling me that, look, yeah, I mean, this tweet was more on the positive side. And whereas if I go and say uh, it is cloudy and cold, let's stay indoor. Here it is. So it has given that, it has a negative sentiment over here, right? So this is calculated. So what has happened is, over the years, these kind of platforms are now being available to us. So although, there are multiple steps involved, multiple algorithms involved, and there are so many decisions we have to take in terms of processing unstructured data for machine learning. At the same time, what has happened is a lot of platforms and tools are being available nowadays to do all of this work, as you just now saw, right? So there's a lot of automation you can do. So in these examples, if you see, it is just a matter of dragging and dropping the right algorithms or the right components from here and creating your model. So it appears, if you look at this particular demo, you would start thinking that we are living in a golden age of machine learning, right? These platforms are making it so simple for us, actually speaking, that yes, I agree that there is a lot of complexity involved, and there are a lot of steps involved, but then platforms are available for me to automate and just do a drag and drop and create my models. But the reality is a little bit far from this, actually. So if there are if you have actually worked on an enterprise application, things are not that straightforward, right? So in this particular example that we just saw, we were taking input from just one um, feed, right? The Twitter feed, this one, and it had just two columns. It basically the feeds. It had just the feeds, and that is all we were processing. But in reality, things are not going to be that simple. In real world projects, you are going to have a lot of data variety. And the data is going to come from multiple sources. What I'm showing here on the screen is just a small subset of the sources. The data could be coming from news articles, chatbots, log files, purchase orders, legal documents, images, audio, video. You might be working on other projects where you have different kinds of data sources. For example, satellite imagery is also a data source, or the information coming from mobile applications, which also has value for different businesses. And so if you look at that, if I take an example over here, I was doing risk identification uh, many years back, and in those days, of course, machine learning was not that advanced and mature. But if you just look at the complexity involved in a real project, so in order to do risk identification, I had to get data from multiple sources, like for example, um, the historical risk assessment that was already stored in uh, some of the data sources. Then also refinery operations database, which again was a free text description of risk. So all this data was available in some of the applications that were there. And then the maintenance reports, which were in thousands, or their count was in thousands, the maintenance reports over a number of years. And finally, there were also, there was some external data that I had to use, like weather reports or media reports, and even the national data repositories that a lot of these companies maintain. So this kind of, so you end up having data from multiple sources. Their formats are different. The security requirement, data security requirements are completely different, and therefore your challenges arise from the variety of the data in a real world project. The other challenge that comes into being is from the data volumes. Now, there are many industries where the data that is being generated is in terabytes or petabytes. Just to give an example, if you look at what the CERN experimentation that happens in France, where that's a European agency for nuclear research, where they do this large hadron collider experiments and many other experiments they do. Usually they generate 1 petabyte of data within a minute when they do these experiments actually. Now, how do you handle that kind of a data, and how do you do machine learning on something that is generating 1 petabytes within a minute or so? Then if you look even at other examples, a little bit simpler example like United Nations, right? So when it tries to track its sustainable development goals, it tracks and compares large log files in real time, and it combines it, or it compares it with the news items and also from data coming from Twitter. Also, I had come across one virtual assistant which a company had created, and this was 3 years back, where it was, that virtual assistant was helping their customers, and in order to help their customers, it used to handle almost 100,000 data sheets for any questions that came related to their around 2,000 products, and they had almost 20,000 different pack sizes. Now, if you look at this, this kind of data is huge, and in real world projects, this is where your complexity gets introduced into your machine learning projects. So, in my experience, what has happened is, on the right hand side, if you see machine learning, cognitive analytics, whether you want to do text analysis or speech analysis, there are algorithms, there are platforms, there are models that have come up. But even before you go there and you try to do all of these things, what is more important is try to build your machine or your big data management platform, which has to be very efficient for you to become successful at machine learning. So that's the first step that has been, all the experience that I have got from working on different projects. And what I mean by saying that, you need to have a efficient big data platform, what essentially it means is that there are 5 larger things that you need to take care of. One is what is your strategy, or what is your solution to acquire the content very quickly, and how are you going to scale, whatever solution that you come up with, is that solution scalable? And in that solution, will you be able to reuse the content? That is very important, because when you're talking about big data, or you're talking about petabytes or terabytes of data, you're talking about a lot of bandwidth that is being used. You're talking about a lot of memory, a lot of compute that is being used, and all these things cost a lot. I mean, I would agree that storage is becoming cheaper, but the rest of the things are still expensive. And you have to make sure that you give the most efficient way of handling the content acquisition and content reuse. The second part is efficient content enrichment process. So you would, all the data will need to undergo some kind of enrichment, right? And again, how do you do that when you have tons and tons of files, thousands, millions of files and terabytes of data? So that is something that we also want to look at. The third one is data security and data governance. A lot of the times at the beginning of the project, we probably will not give too much attention to this, but once we get into the project, there will be a lot of questions coming from business that how are we going to secure the data that we are fetching from the data sources. There are some industries where the data has to be secured, like finance, for example. And even in any other industry, even there's a lot of data, like sensitive data, like even HR data, for example, that has to be secured. The fourth point is data traceability and data searchability. Once you do a machine learning model, and if you finish it, you still have to show that the data was trustworthy, right? So you have modified the data in so many places during the entire data journey, and you would have to show that how you have to trace back the data to the original source, so that people trust the data as well as the machine learning model that you have come up with. And then last of all is getting data sets for training and testing. This is also an important, often overlooked when we start some projects. And then when we have some models ready, we then start scrambling for data sets in order to train our or even test our models. Especially if you're trying to do a POC when you still don't have access to your original data sources. So what we'll do is we'll take a look at how do you address these challenges that I just now listed over here. So the first one is, how do you enable, faster data acquisition and enrichment for large volumes of content? Um, I mean, if you look at it principally, the steps are very simple. These are not very, these are not rocket science principles, right? So uh, you would say, yes, fetch the data, all the data that I require, the content or the files, and uh, fetch it along with the metadata, store it in a large storage area so that I don't have to go back to the source systems to get it again and again. And then the second point about how do you acquire that data very quickly and how do you enrich that data? And the answer is basically how do as much as processing in parallel. So there are two thoughts actually, two streams of thoughts actually in this area in how do you process or acquire data very fast. One thought is that you get technologies or platforms where you can process a lot of things in memory. Try to do it in memory and try to avoid IO, like reading and writing of files. Try to do as much processing as possible in memory, so that is much faster. The second thought is do things in parallel. And I would actually go for a combination of both these things. But if someone asked me to choose between the first option of doing acquiring as much memory or buying as much memory as possible and doing it there, or the second option of working with less memory but doing things in parallel, I would go for the second option, because I've seen that doing things in parallel actually brings more efficiency, and you can do things much faster. You can configure things a little bit much better, and you can actually build your own solutions as well. And the third point is how do you do things faster is by, if possible, you can split your content, right? So many times what happens is we fetch huge large documents and we try to process the entire document, whereas if your machine learning requires only some paragraphs or some piece of content, then it is better to split that content and then do things in parallel on all those all those pieces of content. So let's say if you have a document and if you split it into 4 different pieces, then you can actually process the four different pieces in parallel. So overall, the architecture will probably look like this. This is at a high level. So on the left-hand side, you would have data sources. And these data sources could be anything like maybe social media feeds or document libraries or content management systems. And then you need to have a mechanism to actually get this data, or this one. We call it either data extraction, and extract it and ingest it into a store. Now here we are talking about a data lake store, and maybe you will also require some kind of a semi-structured database like a NoSQL database or something like that. Now after that, you would definitely require some pipelines in order to retrieve the data from your data lake and provide it to your machine learning applications or reports or search applications and so on. So overall, it looks like that. But so the key is doing things in parallel. That's what I believe will actually make your data acquisition and enrichment very, very fast. And there are various strategies that are there how to do things in parallel. We have built over here in Nihilent, we have built a framework on building, doing these things in parallel. Now, one thing is parallelism. It can be at 2 levels. One is over here, okay, I'm getting the data from each data source in parallel. That's one thing. But within each pipeline as well, I can even run parallel sub pipelines to get documents in parallel from one data source as well. Now, once you have a parallel solution in place, and as I said, there are different approaches and strategies to do that. How to do the parallelism. But once you have figured out how you want to do that on your project, you can actually then think about the important part is how are you going to store it in your data storage. And we will talk more about it in the subsequent slides, because that's also important. And if you need to have a very disciplined way, a very planned way of storing data in data lake, because that determines how efficient your data retrieval is going to run. So, sorry, 1 second. Yeah. So we'll get on to the next strategy of, or the next challenge that you will face is when you want to do data enrichment of your unstructured data, where do you do it, right? So as I said, broadly, we have these 3 areas of, one is data extraction, then we are storing the data, and then we are actually feeding the data or your output to the applications in the downstream. So where do you actually want to do data enrichment? So do you want to do it during the data ingestion phase, or do you want to do it after you have brought the data into your data storage or data lake, or do you want to do it later, when you are trying to retrieve the data for your machine learning? Now, there are pros and cons, but in most applications, I would suggest, we do it in the data storage layer, all the enrichment that you want to do, because of the simple reason that all your enrichment logic that you write is going to remain in a central place, and that's very important for reuse. And also what happens is you can also keep both the raw data and the enriched data in the same place. So both these elements, first of all, you can reuse your code or your processes that you have written. You can also reuse a lot of this data for different kinds of machine learning use cases that you are trying to develop. Now, not in all cases, you might not be able to do this. There are some examples like the CERN example that I spoke about earlier, where when they run these experiments in their underground tunnels, they actually generate petabytes of data in a minute. Now it's impossible to store that kind of a data in your data lake, and therefore they have to extract a lot of this data, and they cannot. So they have to extract the data and then throw away the raw data. So in that case, this kind, you might probably want you to have your enrichment logic or the extraction logic during your data ingestion or extraction phase itself. But again, the disadvantage is that you lose all the raw data. So what you get is you extract the data and then just put the processed data or the usable data over here, and then later if you need the raw data, then you still, you don't have the raw data. That's the disadvantage. But in some situations where there is a lot of data coming in, you probably don't have an option, and you have to do enrichment during the extraction itself. So again, you have to have a proper framework to decide where you want to do the processing, where you want to do the data enrichment, and so on. It's what I have seen is what we have done at Nihilent is we have created again frameworks to decide where we want to do it and how we want to do it, and that's probably something that you will also want to do for your projects as well. The third aspect is data security. As I said, a lot of this data that you acquire from your various data sources, you're trying to break it in a central place like a data lake, and there is going to be demands on you to make sure that you are getting a copy of that original data, and therefore it has to be secured. There will be a lot of sensitive data also sometimes that has to be secured. So I think 4 large areas need to be covered when you talk about data security. And see, data lakes on their own, they don't provide data security. Most of these data lakes that are available today, right? Data lakes are very flexible in nature because they allow you to store large amounts of data in any format. But then on the other side, they have some drawbacks, right? So they don't give you any structure to store the data. You have to think about the structure of how you want to store it. And then they don't give you any data, any tools or mechanisms to actually store your or secure your data automatically. So you have to build a mechanism to do that. And I think you have to take care of all these 4 things. Authentication is a given, and everyone has some directory services against which you can authenticate. But then access control is important, especially if you are asked to provide document level security, or even or if you're asked to provide role-based access as well to certain data sets. Then network security is important. Encryption, how do you encrypt the data when the data is at rest in your system or the data lake, or when data is in transit. Now here again, you have to have a plan to do all of these, and I believe all 4 of these are required. I don't think you can just say I will do 2 of these 4 and still my data would be secure. So that would not be a great way of looking at data security. I think all 4 of these elements are very important. Then, as I said, the data retrieval from your data lake, right? So once you acquire the data, put it into data lake, then you did some processing on it. You ran your machine learning algorithms, and during those machine learning algorithms, we saw you have created multiple copies of your data after processing. At each step of processing, how do you then make sure that all the data you can find at the end of the day, right? If you end up putting millions of files in your data lake and petabytes of file, and if data scientists are not able to find that data, then it's of no use. Therefore, there has to be a lot of structured way of storing it. Again, data lakes, most data lakes on their own, they don't provide any structure. We have to come up with our own structure and a plan to do it. Zoning data lakes helps a lot in terms of finding the data and also governing the data as well. Um, these are just some examples that we at Nihilent typically use in zoning the data, the data in the data lakes. Usually, you would like to keep a data, like the raw zone would be definitely separate because you might want to reuse that data for different purposes. Then the process zone is required, a sensitive data zone is required, and lastly, a data science zone is required, where you actually keep a lot of this process data for data scientists to use for machine learning. It typically will be in the format of large matrices, the data science zone, where you combine data and create large matrices for the data scientists. Then the last, the last area that I wanted to talk about is data traceability and searching of data sets. So data traceability is something like, when you are going through this entire journey of data updates and, you are enriching the data and then you are modifying the data. Obviously, there are going to be questions regarding, how do you trace data back? Like you want to make sure that whatever changes you have done, they are right, and the business has to agree that that your data can be traced back to the original source. So what we have done is we have come up with a framework where we actually capture a lot of this data, the business data, like who's the owner of the data and the business need of the data, the business model of the data. We combine it with the technical data catalog or the metadata. We also have framework to map the source systems to the data lake zones. And using all of these three, we provide data traceability and data lineage. And this is something very important in a machine learning project because in order to prove that your output is correct or as desired by the business, this is something that is a very important element to show how the data has been modified, by when, by which process, where, what business rules were used. And that traceability is highly important in order to gain trust from the people who are going to use your machine learning algorithms. The last, one of the points is searching data sets, and this occurs so many times. When your data lake starts, or even your other data stores, when they start getting very large in terms of number of files or the number of contents, that you're storing, it just becomes impossible to go and find the required content, right? So if a data scientist wants to do some machine learning, and they want to look at the raw data, and already you have millions of files over there, how are they going to find it? And therefore there's a mechanism that has to be put in place in order to, there has to be an interface for people to find the data in your data lake. Now, not necessary that you have to index the content of each file itself, but it helps if you can provide search on the data sets, the data set or the zones that we have created in the data lake. So that itself can be a very good help for the users of your unstructured data to find the content very quickly. And lastly, as I said, this is a highly underestimated or overlooked scenario where we start on a machine learning project, and if we don't have access to the content to our production level data at that point of time, there is no way that you will have some high quality data sets to actually start doing your experimentation or training or testing. And therefore I think it's very important, and I think I come across this problem in almost all the projects where we have to start thinking of where am I going to get some good data sets in order to actually train my applications or my modules. And I think here are some very good examples, open source examples available. You might be using it. Kaggle is the most, well-known data repository where there are many data sets, but there are a couple of others. Some are a little bit older, like the ones like from Reuters. It is a little bit dated, but still it is very useful. Uh, so, and there are more number of open data sets available other than what you see over here on this slide. So with that, I come to my last part of my presentation, which is a quick case study. So this is what we did for one of our very large customer, a very large organization, which works globally in almost 70 different countries. And what they do is, the problem, the challenge that they wanted to do is that they wanted to actually analyze the spend that happens in all these different countries for different reasons that they do for their own business. And in different countries and different continents, they are using different ERP systems and they have different procurement organizations. And the important part is that they want to actually do a spend analytics across all these different countries. So how we help them is that we created architecture similar to what I showed earlier. And all this invoicing data is got into a data lake. We have all the elements put in over there, like the zoning of the data lake and provisioning the data security, because the data is some of the data is sensitive, invoicing data coming from different countries. So there are owners for all these different ERP systems who would not like to have somebody else, unauthorized people, to look at the data. So we have implemented all the elements that I talked about earlier on that data lake. The amount of data that comes in is huge in terms of millions of invoices that are created in a year, and also there are multiple line items within each invoice. So the processing is very, very large. On the other side, there is also the spend. The categories of spend are also very high in number. They're in thousands, and those categories are hierarchical in nature. So therefore, what we have developed is earlier the system was based on some rules where there used to be a manual intervention where people used to actually categorize the invoicing based on certain rules. Now we have replaced that rule-based system by machine learning system, where now categorization happens on the machine learning model that has been developed. And this model has been very accurate, and the entire process is streamlined right from content acquisition or the invoice acquisition, storing it securely in data lake, and then processing it as per the created, and categorizing the spend the invoice as per the categories that have been listed. One advantage of this solution is that it is capable of taking feedback from the user, right? So if there's a user who thinks that the category needs to be different, then that feedback is actually inculcated into the model itself, and the model takes that feedback for further processing. So in summary, what I feel is very two simple suggestions. One is, if we want to do machine learning and advanced analytics on a large scale, we have to begin with some baseline data management principles that has to be set in your organization before we start doing that. And the second is that we upfront, we have to start planning for scalability and how to do things in parallel. Efficient data management is very important because you very quickly jump into multiple terabytes of data. And then data security and data traceability is equally important for any kind of data analytics or machine learning programs that you want to run. So with that, I end my presentation. Thank you very much for listening to me. If you have any questions, there is a questions panel on your screen, or you could, if you want to ask any questions later, then please feel free to write to me at my email, which is prashant.pawar@nihilent.com, or I also have another email ID, which is globalbizdev@nihilent.com. Thank you.
Thanks, Prashant. We have some questions here. Our first question from Pooja, and the question is,
Sure.
how can we get whether the comment is positive or negative, or how the word analysis is being carried out?
Yes. So there is a principle. I mean, machine learning is based on uh, the machines learn from the past data, right? So at a very basic level, what happens is you have to feed in your past. So this example that I showed you, where we had the tweets. So there in that example, we had 160,000 tweets, and they were a portion of them were fed into the algorithm, which basically there are ready-made algorithms available to analyze the sentiments of text, but you basically feed your data because you will have to train your model based on the data that you have. And so there are different ways of doing it. There are some models which are called as supervised models, where you already know certain tweet is positive, right? So if you say, okay, I have fed these 500 tweets to my model, out of those 500, these 400 are positive sentiment tweets, then the machine learning algorithm will understand, okay, if there are words like good and happy and thank you and like you, love you, so those are positive sentiments, or warm weather, sunny weather, right? So that this is kind of a supervised model that you use for your machine learning. So you feed in the data and you tell your machine that these tweets are positive, so that your model or your machine knows that these are positive tweets. At the same time, you feed in some negative sentiment tweets, like today is a cloudy weather, I would like to stay at home. So, and then you say these are negative tweets, and that's how you train your model or your machine. And then once that model is trained, so any new feed or a new tweet that comes in, that will essentially so your machine will look at your past data, and then it will tell you whether the new tweet that has come in, whether it looks positive or negative.
Okay. The next question is, furthering the social media sentiment analysis. Example, could you name some service to procure Facebook post data or Twitter data?
Facebook, sorry, what was it? Facebook or Twitter data?
Yeah. So could you name some service to procure the
Uh,
Facebook post data or Twitter post data?
no, so both is Facebook and Twitter, they have their APIs. So you can actually capture the data from the APIs that they provide, the feeds that they provide. In fact, if you go to Google, you will find some open source programs already written on how to capture the feeds that you want from both Facebook, Twitter, and from other social media applications also. So I don't think it is a very difficult thing to do nowadays. It's pretty straightforward.
Moving on, our next question is, ML challenges arise from data volume. Can you elaborate with an example for the same or for data velocity?
Yeah, data velocity, right? I mean, it is, for example, your data like IoT data, which comes like continuously, right, in real time, like your smart meters or even your Twitter feeds, Facebook, all this data is coming in real time. So the data velocity is involved over there. And in data velocity, the same complications that I mentioned about data volume or data variety, those will arise as well. So how do you, when you're getting data in real time, when you have very fast data velocity, you have to take decisions about how much of the data you want to store, where you want to store, and the same questions will arise whether you want to extract the required information while you are actually capturing the data, or you first want to capture the data into your data lake and then process it. And typically, over a period of time, again, this becomes a huge amount of data, right? So it becomes into petabytes. So for example, if you're working for a telecom company, the voice call records, they also will come in stream format, one after the other. And over a period of 1 year, you will end up having like petabytes of those call records, which if you want to process that, then that becomes a very large size of data that you have to process. And then again, so what comes into picture is how do you want to process it in order to minimize the price that you have to spend for your compute and memory and storage. So yes, I think data streaming is, or data velocity is equally, it's equally complex as compared to data volume and data variety.
Okay. The next question is, does new offerings from Microsoft on virtual assistants and Power automate integrate with data services?
Okay, I'm not sure whether I really understood what the person wanted to ask, but I'll attempt to actually answer the way I have understood the question.
Yeah.
Yeah. So, yeah. So yeah, I mean, if you look at Microsoft and Azure, there are multiple services that are available. Some of these are PaaS services, and some of these are available as APIs, as I demonstrated both of these today. And what happens is now, when you say data services, now data services is a very broad term, not only in Microsoft's world, but any other platform. If you go Google for that matter, or AWS, or even IBM, they have multiple data services, ranging from simple things like just SQL Server as a service, right? So SQL Server database as a service is one service. Then there is something called as data lake as a service. So there are hundreds of services that these platforms are providing. And therefore, I think what, I would say we are living in a golden age, because I think for us now what has happened is we have to have uh, the skills just to integrate these different services and understand how best these different services work. What is the most efficient way I can use these different services. How can I actually should I use data, so a data lake or a data warehouse or a simple database in the cloud, or should I just go and use only the APIs that are available? So I don't even have to even create a data warehouse in that case. I could probably just use some of the APIs, or I don't even have to create a machine learning virtual machine in the cloud. I can go and use some APIs. So I think it is up to us on how we want to integrate all of these different services that are available in the data services as well as in the machine learning space.
Sure. There's one more follow-up question to this. Any best practices to ensure advanced analytics and ML projects don't remain POCs, but they get accepted as implementation?
Yeah, exactly. And I think the 5 things that I listed at the end of my presentation, that I think those are important if you don't want that to happen, that it ends up as a POC, right? Because your machine learning has to be very robust. And I think all those 5 areas that I listed at the in my presentation about how do you secure your data, how do you actually make it easy for people to find it, how do you make sure that there's enough flexibility in your experimentation, because what will happen is you create an experiment, you create a model, maybe that is not something 100% that the business expects, and they will expect something else, and you have to be
Prashant,
ready to change your model, to do the processing all over again, and that flexibility you need in order to quickly change. Hello,
Prashant, your voice was not clear. It was lagging behind. Now it is better.
Mandeep, hello. Yeah, Mandeep, I think, am I audible?
Yeah, you audible.
Okay, sorry. Um, were you able to hear me when I completed the answer, or was there another question after that?
There wasn't any other question after that, and your voice was not clear. So if you can just, in short, repeat the query again, so it will be really great.
Yeah, the last query was, I think, that how do you make sure that your project doesn't end into a POC, and
That's right.
right, and that it should become a full-fledged production. And as I said, the five things that I mentioned, I think that if you do that, that will give you enough flexibility and the robustness. Because what will happen is, in machine learning, typically you have to do a lot of experimentation. Business will ask you to do different scenarios, and you have to have an ability to do those scenarios very quickly. And the only way you can do those scenarios very quickly is by having an ability to actually rerun your entire processes again and again with different data management model on the back achieve that.
Sure. Prashant, the next question is with reference to the case study that you presented. So there are two questions for it. One, which data lake was used for this case study? And the other one is, how were you collecting feedback from users as explained in the case study?
Okay, so for the case study, I'm sorry, I cannot disclose actually the data lake, but it was one of the industry leading data lakes that was used. It was basically based on the Hadoop platform, but I cannot name actually the version of the Hadoop that was used, but I think that should give you an idea about the kind of data lake that was used over here. I think the second question was, I mean, the second part of the question, what was it? Sorry, I forgot.
It was, how were you collecting the feedback from users?
Yeah, so yeah, the feedback basically was very simple, right? In terms of accuracy of the spend categorization. So one is obviously, when you run a machine learning project, you already have you basically do your own evaluation of the accuracy of how you do it, right? So you have multiple methods to do it, like confusion matrix and so on. But in this case, you also have the end users look at the categorization that the machine learning program has done and give feedback whether that categorization has been correct or it has been misleading. So you take some samples and have the end user to go through some of the samples of your output and basically get a feedback on whether that particular what output of your machine learning is correct or not.
Okay. The next question is, do we use any mathematical formulation for data analysis?
Sorry, Amandeep, I was not able to hear that.
The next question is, do we use any mathematical formulation for data analysis?
Yes, I think in machine learning, I mean, if you are aware, all machine learning algorithms, mostly they are based on mathematical premises, and a lot of statistical premises are used over there, right? So whichever kind of approach you take, whether you take supervised machine learning, unsupervised machine learning, all of these are based on algorithms that are based on statistical. A lot of them are based on mathematical models as well. But for this particular webinar, it's difficult to go into each of those algorithms and start discussing what those algorithms are based on, which kind of mathematical models they're based on. So that's probably a different topic, and it's a very wide topic and a very deep topic as well. So I would request that if somebody is really interested in understanding what kind of mathematical models these algorithms are based on, there's a lot of documentation available everywhere, right? I mean, a lot of universities, they have this information available. There is a lot of even this kind of information available on on websites of leading cloud providers. So there's tons of information available for this.
Okay. Can you share your experience on handling ML model lifecycle, like model retraining, validations, and deployment?
Again, I think this is a little bit of an open question, but I would say that yeah, model retraining, deployment, yeah, you probably have to do it multiple times, right, in a life cycle. It never happens that you can get it everything right the first time, and that's why that discipline is very important in terms of keeping your data in a format that is reusable. Making sure that you have a very good system in place to do parallel processing, because all that is going to help you to do these things over and over again until you get to the right model and the right output, where your business agrees with that. So yeah, there are going to be multiple iterations in the life cycle.
Okay. Next question is, which open source tools are used at Nihilent for big data engineering?
I think we use many open source systems. I mean, we use a lot of these NLP, the libraries that I showed on one of the slides. We use almost all of those. There are multiple tools available as well, which are based on either Python or R or Scala. We also use Spark a lot in our projects. Spark for doing data processing. Then apart from this, I think we use open source databases to store information like MySQL and Postgres. So there are many open source tools, programs, platforms that we use. And I think that's the beauty of machine learning and big data management, right? I mean, I don't think anyone can do these big data projects and machine learning projects without actually touching my open source one way or the other. And if you look at all these major platforms, if you look at Google, or even if you look at Microsoft Azure, in the platform itself, all these open source technologies have been embedded, right? So even if you use these platforms, you would end up using some of those open source technologies.
That's right. Um, The next question is, why can't we use rule engine like rules instead of machine learning?
No, yes, of course. I mean, see, that's a decision you'll have to take based on what is the size of your data and what is that you want to get as an output. I mean, definitely machine learning is not a solution for everything. Like if there are applications where you know exactly what you want to retrieve and it is pretty simple, and if rule-based engine is enough for you, I think that's the way to go, right? You don't have to actually try and apply machine learning for each and every scenario. Machine learning can get in a little bit complex that we saw, right? And you probably will require a lot of other systems in order to do machine learning. But yes, I agree. I mean, I have done rule-based processing very recently, maybe a year back, where the requirement was very simple in terms of I had to make sure that the name of the person appearing on a payslip was similar to what the name was exactly in the database, right? So for this, you don't need to actually try and fit machine learning to solve this kind of a problem. You can use it. You can use simple things like rule-based systems.
Okay, the next question is, to allow for role-based personalization in end user experience, what care does one need to take in data preparation?
Oh, so role-based, yes, I think this is a very good question because I think what happens is if you don't know, you're right, when you are actually in data preparation, you're actually acquiring the data, right, from your data sources. Whether you're acquiring it from ERP, CRM, or SAP system or a document management system, you have to know what permissions are there on that particular piece of content in the data source itself, and you should have an ability to actually extract that permission set also along with the content. And I think then it makes it easier for you to apply role-based permissions when the data comes into your system, which is basically probably going to be a data lake or a machine learning storage somewhere, right? So then it becomes easier for you to uh, apply the same data security or role-based permissions that were there in the source system into your system as well. Now, if you don't get that kind of an information along with your content, then probably you have to do a little bit of more work, right? So you probably have to again reassign and rethink about what different data sets in your data lake are going to. You have to assign different permissions, and you'll probably have to create some different roles specifically for your data lake and try to mimic the similar role-based access that was there in the data source itself. So yeah, it can become a little bit tricky if you're not able to extract the permissions in information from the source systems.
Okay, the next one is, what is the standard method for removing unwanted words and HTML tags in the content?
So there are ready-made functions available if you're using Python. If you are using R, there are functions available where they will take out all the standard HTML content from there, even the punctuations also.
Okay. And the next one is, can you specify the pros and cons of the NoSQL databases available for large sets of data?
Okay. No, so pros are very straightforward, right? I mean, you can store semi-structured data in NoSQL databases. All the JSON kind of information that you're going to collect nowadays. A lot of the feeds that you're going to get is in JSON format. So the pros are basically you can collect it, store it in a NoSQL database, and also it gives you the flexibility of in the future if your schema changes, the input if the input feed schema changes for you, you don't have to worry too much about how you are going to fit that new schema into your NoSQL database. So that's very straightforward. So it's a pro basically in terms of it gives you the flexibility to handle all the schema changes that happen over the time. On the cons side, essentially, one of the things is over the last few years, the NoSQL databases can handle large amount of data. So that is not a limitation anymore. Searching on NoSQL also is, or querying NoSQL is also pretty straightforward nowadays. So on the cons side, I think the only thing that would come to my mind at this point of time is, essentially how do you, if you want to merge or if you want to transform certain data sets, it takes a little bit longer time compared to your relational data sources, right? So that processing takes a little bit longer. So if you have data sets which has millions of records and now you want to change something across all those million records, you have to be very careful, first of all, in terms of what you're changing, because you're going to have different schemas in your NoSQL database. So you have to make sure that you understand what you are changing, first of all, that it doesn't have any impact on the rest of your data. And it is going to be a little bit slower in terms of processing it. So I think you have to bear with that if you have to enjoy the advantages of NoSQL. Then there are some downsides of it as well. But I don't think I don't think you end up actually updating a lot of data in NoSQL. I mean, in very few use cases, probably you are going to do that. So that should be okay.
Yes, and the follow-up question is, if data lake is no non-SQL database, then does it mean it will be file system for storing data? And if not, which is suggested storage system?
No, yeah. So if it is a no-SQL database, then yes, I think you are referring to HDFS file system. I mean, HDFS is the most commonly used across. I mean, all most major data lakes support HDFS, and HDFS has been a proven technology in terms of storing large files. It can store large files. Underneath, basically, it stores it in chunks, and that's how it is very fast, because it can be retrieved and stored in chunks parallelly, and that's the strong point of HDFS file system. And yeah, that is the most common one, supported by all the major data lakes that are available currently in the industry. So yes, other than NoSQL database, the basically answer is anything that basically uses HDFS.
The next question is, what are some ways to do quality assessment of data at different stages?
Okay, quality assessment is okay, different stages. I mean, it's a very broad question. You will have to determine what you want to check at every stage and what kind of processing you're doing. But some examples are like, first is the record count, for example, right? So I got the data from data sources, and after I have done my processing, can I account for all the data, or have I missed some data in between? Because if my project involves doing aggregations or some mathematical calculations, then in that case, if I, in my processing steps, for some reason, by oversight or because of some errors happening, if I lose some data or I drop some data in between, then my end output is not going to be correct, right? So one way to check is to roughly check, whether the counts are correct, whether I am processing all the data or not. The other thing is, depending on what you're trying to achieve, you might also want to compare, the aggregate values or whatever you have calculated with the original data source separately, right? And that's an important part of building your data, the data processing, that you are building. At every step, you have to make sure that when you're developing, you also develop these checks as well in parallel, and not leave it to the end of the project, where you at the end of the project then you start thinking, how am I going to test the data? Instead of that, right from the beginning itself, for every step, you would want to probably write some extra functions to make sure that you are comparing the data while it is being developed.
Okay. And the last question is, How does interpretation acquired from past data stand valid in present or future? And how does ML handle uncertainty?
Well, yes, past data. Yeah, I think yeah, if the business understanding of past data is different than what it is currently there, then uh, you definitely need to segregate that actually. So I don't so either there are two ways. One is you segregate that completely, or you basically scale it as you do it, right? You scale the old data so that it matches the new data. So for example, if the metrics used in your old data was different, and now the unit of measurement is different in this case, for example, right? The unit of measurement was earlier different, now it is different. Then you have to rescale the old data so that it matches the unit of measurement of the new data, so that the data has to be uniform in terms of what it represents or what the context is. But again, these are some standard methods of doing it, which are very well documented. If you're going through a machine learning process, there are multiple methods, by the way, just not one method of standardizing data, depending on what kind of standardization you're looking at. I just talked about one example of units being different over a period of time. There can be any other ways that your data might differ over a period of time. Like for example, um, the size of measurement, the it might itself that might change over a period of time. The meaning of data might itself change, or even your simple things like how you store date and timestamp, that might change over a period of time in the source system. So multiple reasons can be there for why your old data might differ from the new data, and the only way to bring it is to make it uniform by applying different techniques.
Okay, so in the interest of time, we will not be able to take any further questions, but I will request you to please drop your further queries at pune@nascom.in, and our team will get in touch with you and address those. We hope that you found today's webinar informative and it was a good food for thought. Thanks to you, Prashant, and thanks to the Nihilent team for sharing this knowledge with us. And to know more about our upcoming webinars and the other initiatives, you can follow us on the social media handles, or you can also visit our website and know about the upcoming events. Signing off for today. Thank you everyone for joining.
Thank you, Amandeep. Thanks everyone. Bye.